Welcome! In this video, we'll begin our journey into the fascinating world of motion. For centuries, thinkers and scientists have tried to understand why and how objects move. The principles we'll discuss form the bedrock of classical mechanics, helping us describe everything from a rolling ball to the orbits of planets. Let's start by looking back at some early ideas about motion, specifically those of the ancient Greek philosopher Aristotle. Aristotle believed that an external force is continuously required to keep an object moving. If you stop pushing or pulling, the object naturally stops. This seemed like common sense, because in everyday life, things do slow down and stop unless we keep applying a force. For instance, a cart needs a horse to keep pulling it, or a ball rolling on the ground eventually comes to a halt. However, Aristotle's idea didn't fully account for invisible forces like friction and air resistance. He believed that the natural state of an object was to be at rest. To keep it moving, a force was always necessary. This is now known as Aristotle's fallacy. While it seems intuitive from our daily interactions with a world full of friction, it doesn't accurately describe how motion works in an idealized frictionless scenario. The next major leap in understanding motion came from Galileo Galilei. Through careful experiments and brilliant thought experiments, Galileo challenged Aristotle's views. He imagined rolling balls on inclined planes. A ball rolling down an incline speeds up. A ball rolling up an incline slows down. So, he reasoned if a ball rolls on a perfectly horizontal surface with no friction, it should neither speed up nor slow down. It should continue moving forever at a constant speed. This fundamental insight led to the concept of inertia. Inertia is the property of an object to resist changes in its state of motion. In simpler terms, objects want to keep doing what they are already doing. Sir Isaac Newton later formalized this as his first law of motion, often called the law of inertia. It states, an object at rest will stay at rest, and an object in motion will stay in motion with the same speed and in the same direction, unless acted upon by an unbalanced external force. Let's look at some everyday examples of inertia. Imagine a book resting on a table. It will stay there forever unless you or something else applies a force to move it. That's inertia of rest. Now, think of a hockey puck gliding on a very smooth, almost frictionless ice surface. It will continue to glide in a straight line at a constant speed for a long time. That's inertia of motion. If a hockey stick hits it, that's an external force changing its motion. You experience inertia every time you're in a vehicle. If a bus you're standing in suddenly starts moving forward, your body tends to lurch backward. This is because your body, due to inertia, wants to stay at rest while the bus moves forward under you. Conversely, if the bus suddenly stops, you lurch forward. Your body wants to continue moving forward due to inertia while the bus has stopped. Here's another one. If you shake a tree branch with apples on it, the apples might fall off. The branch moves, but the apples, due to their inertia, tend to stay in their original position and thus detach. Or the classic coin and card trick: place a card over a glass and a coin on the card. If you flick the card away quickly, the coin, due to its inertia of rest, doesn't move with the card and drops into the glass. So, inertia is a fundamental property of matter. Understanding it is the first step towards understanding Newton's other laws of motion, which we'll explore in future videos. Thanks for watching.